Imagine standing in front of the greatest mind of the 20th century, Albert Einstein. The room is silent. Every idea you speak could define your career. Most people would agree with him. Most would stay quiet. But one man didn't. Richard Feynman questioned Einstein's ideas openly, not to insult him, not to impress anyone, but to chase the truth. And instead of anger, something unexpected happened. Einstein listened. He respected him. This is not a story about ego or genius. It's a story about how real science moves forward, and why questioning even the greatest minds can change the world. Richard Feynman's greatest intellectual strength was his refusal to bow to authority, no matter how legendary that authority was. In a scientific culture where names like Einstein carried enormous weight, Feynman stood apart by insisting that nature itself was the only true judge of ideas. To him, it was irrelevant whether a concept came from a Nobel Prize winner or a first-year student. What mattered was whether it actually matched reality. This attitude was not rebellious for the sake of rebellion. It was deeply principled. Feynman understood that science stagnates the moment respect turns into worship, and he made it his mission to keep questioning alive, even when the ideas being questioned belonged to giants like Einstein. From an early age, Feynman was trained to think this way. His father taught him to look beyond labels and reputations, encouraging him to understand how things truly worked, rather than memorizing names or accepted explanations. This upbringing shaped Feynman into a thinker who felt no intimidation in the presence of greatness. When he entered the professional world of physics, he noticed that many scientists were reluctant to challenge established figures, not because the ideas were flawless, but because the people behind them were famous. Feynman found this deeply troubling. He believed that once fear enters scientific thinking, honesty disappears. This mindset became especially important when Feynman encountered the towering influence of Albert Einstein. Einstein had revolutionized physics, and his theories were rightly celebrated. But Feynman refused to treat them as sacred. He admired Einstein's brilliance, yet he never confused admiration with agreement. Feynman openly analyzed Einstein's ideas with the same critical lens he used for any other theory. He believed that treating Einstein differently would actually be disrespectful, because true respect in science means taking ideas seriously enough to test them, question them, and even challenge them if necessary. What made Feynman unique was the tone of his challenge. He did not attack Einstein personally, nor did he try to prove himself superior. Instead, he questioned ideas calmly, logically, and with deep curiosity. Feynman often pointed out that even Einstein himself had rejected blind authority earlier in his career by challenging Newtonian physics. In that sense, Feynman was not opposing Einstein's legacy, he was continuing it. This parallel did not go unnoticed. Einstein understood that progress depends on people who are brave enough to ask uncomfortable questions. Feynman's refusal to accept authority was also rooted in his belief that uncertainty is not a flaw in science, but its greatest strength. While many scientists felt pressure to appear confident and certain, Feynman openly admitted when he did not understand something. He believed that saying, "I don't know," was the beginning of real discovery. This honesty extended to his treatment of Einstein's ideas. If something didn't fully make sense, Feynman refused to pretend otherwise, regardless of who had proposed it. That kind of intellectual courage is rare, and it is precisely what earns genuine respect among great thinkers. Einstein, despite his public image as an untouchable genius, deeply valued this honesty. He knew better than anyone that scientific breakthroughs come from challenging accepted truths. Feynman's approach mirrored Einstein's own youthful defiance, and this created an unspoken bond between them. Feynman did not treat Einstein as an untouchable icon. He treated him as a fellow explorer of reality. That equality, grounded in respect rather than ego, is what made their intellectual relationship so meaningful. In the end, Richard Feynman earned Einstein's respect not by agreeing with him, but by daring to question him in the right way. He showed that real respect in science is not silence or obedience, but the courage to test ideas honestly and follow evidence wherever it leads. By rejecting authority and choosing truth over reputation, Feynman demonstrated the very spirit that had once made Einstein great. That is why his challenges were not seen as insults, but as contributions. And that is how Richard Feynman proved that even the greatest minds deserve questions, because questions are how science stays alive. Richard Feynman believed that if an idea could not be explained clearly, then it was not truly understood, no matter how impressive the mathematics looked on paper. In the world of theoretical physics, where complexity often became a badge of honor, Feynman took the opposite approach. He was deeply suspicious of ideas that relied on intimidating equations without offering intuitive meaning. To him, mathematics was a tool, not a shield. This philosophy placed him in rare alignment with Albert Einstein, who also believed that the deepest truths of nature should have an underlying simplicity, even if they were discovered through difficult work. At the time Feynman was developing his ideas, quantum mechanics was notorious for being mathematically dense and conceptually confusing. Many physicists could manipulate the equations well enough to get correct results, but few could explain what was actually happening in physical terms. Feynman found this unacceptable. He didn't just want to calculate answers, he wanted to understand processes. This desire pushed him to search for a clearer way to think about particle interactions, not just compute them. That search led to one of the most revolutionary contributions in modern physics, Feynman diagrams. Instead of writing pages of abstract symbols, Feynman introduced simple visual representations that showed how particles move, interact, and exchange energy over time. These diagrams were not merely illustrations, they were powerful thinking tools. They allowed physicists to see complex quantum events as step-by-step processes transforming chaos into something almost story-like. With a glance, one could grasp interactions that previously required exhausting calculations. What made this innovation so profound was that it did not simplify by ignoring reality. Feynman's clarity was not superficial. His diagrams captured the same physics as the equations, but in a way that aligned with human intuition. This reflected a core belief he shared with Einstein. Simplicity should emerge from truth, not replace it. Einstein had long argued that the best theories are those that reduce complexity without losing essence, and Feynman's work embodied that ideal perfectly. Einstein recognized that Feynman's approach represented a new way of thinking rather than just a technical shortcut. While Einstein struggled philosophically with certain aspects of quantum mechanics, he still respected honest attempts to make sense of it. Feynman did not claim to fix quantum theory or make it more comfortable. Instead, he accepted its strange nature and focused on describing it clearly. This willingness to confront reality as it is, rather than as we wish it to be, resonated deeply with Einstein's own scientific values. Feynman's commitment to clarity extended beyond research and into teaching. He believed that confusing explanations were often a sign of confused thinking. When students failed to understand, he did not blame their intelligence, he questioned the explanation itself. This attitude stood in contrast to the academic culture of the time, which often treated difficulty as proof of depth. Feynman rejected that idea completely. For him, true depth revealed itself through simplicity, not obscurity. This clarity also required intellectual bravery. Simplifying an idea exposes it to scrutiny. Hidden behind complexity, mistakes can survive for years. By making ideas transparent, Feynman invited criticism and testing. He understood that clarity makes it easier to be proven wrong, but he welcomed that risk. This openness to being wrong was something Einstein admired greatly because it lies at the heart of scientific progress. In essence, Feynman's revolutionary thinking was not about making physics easier, but about making it honest. He stripped away unnecessary layers until only the essential structure remained. In doing so, he gave physicists new eyes to see the quantum world and new language to describe it. Einstein saw in Feynman a thinker who understood that clarity is not the enemy of sophistication, but its highest form. That shared belief connected them across generations and showed that the most powerful ideas are not those that impress at first glance, but those that illuminate understanding. One of the deepest intellectual divides in modern physics was Albert Einstein's discomfort with the fundamental randomness of quantum mechanics. Einstein believed passionately that the universe should be governed by clear, deterministic laws where events unfold according to precise causes. To him, the idea that nature could behave probabilistically at its most basic level felt incomplete, almost unsatisfying. His famous remark that God does not play dice captured this unease. Richard Feynman, however, approached this problem from a completely different direction, and it was this contrast that revealed the true strength of his scientific mindset. Feynman did not ask whether quantum mechanics felt philosophically pleasing, he asked whether it worked. Instead of trying to reshape the theory to fit human expectations of order, he accepted nature's strange behavior on its own terms. For Feynman, the universe was under no obligation to make sense to our intuition. If experiments showed that particles behaved unpredictably, then unpredictability was not a flaw in the theory but a feature of reality itself. This willingness to accept uncomfortable truths set Feynman apart and placed him at odds with Einstein's deeper instincts. Rather than debating quantum mechanics at a purely philosophical level, Feynman focused relentlessly on experimental results. He believed that the ultimate judge of any theory was not elegance or comfort, but agreement with observation. Quantum mechanics, strange as it was, produced predictions of astonishing accuracy. Feynman respected that. He once remarked that it was not his job to explain why nature behaved this way in a comforting narrative, but to describe how it behaved accurately enough that predictions could be tested and confirmed. This practical attitude allowed him to move forward where others remained stuck. Einstein's objections to quantum mechanics were thoughtful and profound, and Feynman never dismissed them lightly. In fact, Feynman admired Einstein's insistence on deeper explanations. However, Feynman recognized a limit. Refusing to work with a theory simply because it felt incomplete could slow progress. Instead of waiting for a perfect interpretation, Feynman embraced the theory's predictive power and pushed it further. This approach led to major advances, especially in understanding how particles interact at the quantum level. Feynman's work showed that accepting randomness did not mean abandoning rigor. His calculations were precise, his predictions testable, and his results consistently matched experiments. By developing quantum electrodynamics into one of the most accurate theories in science, Feynman demonstrated that probabilistic laws could be just as reliable as deterministic ones. This achievement challenged the intuition that certainty requires determinism, revealing that uncertainty, when handled correctly, can be just as powerful. Einstein recognized this success even if he remained philosophically unconvinced. He could see that Feynman was not promoting chaos, but discipline of a different kind. Feynman's acceptance of quantum randomness was not careless, it was grounded in evidence and mathematical consistency. This distinction mattered deeply. Einstein valued intellectual honesty, and Feynman's refusal to deny experimental truth for the sake of philosophical comfort exemplified that honesty. The contrast between Einstein and Feynman on quantum mechanics highlights a crucial lesson about science. Progress does not always come from resolving every philosophical doubt before moving forward. Sometimes it comes from working with the best available description of reality and refining it through experiment and calculation. Feynman embodied this forward-moving spirit. He acknowledged the mystery at the heart of quantum mechanics without letting it paralyze him. In the end, Feynman did not defeat Einstein's objections, nor did he try to. Instead, he showed a different way of engaging with uncertainty by accepting it, using it, and building reliable knowledge on top of it. Einstein may not have liked the dice, but he respected the player who knew how to read the table. That respect came from seeing in Feynman a scientist who placed truth above comfort and results above philosophical preference, ensuring that physics continued to advance even when reality refused to behave as expected. Richard Feynman earned respect not through confrontation or ego, but through a rare form of intellectual honesty that placed truth above personal pride. He never approached Einstein or anyone else with the goal of winning an argument. Instead, his only loyalty was to understanding how nature actually worked. This attitude shaped every challenge he made. When Feynman questioned ideas, he did so openly and transparently, admitting what he knew, what he didn't know, and where uncertainty remained. In a world where many scientists felt pressure to appear confident and infallible, this humility stood out. Feynman believed that pretending to understand something was far more dangerous than admitting confusion. He openly criticized the habit of hiding ignorance behind complex language or mathematical formalism. To him, honesty meant exposing ideas to daylight where they could be tested, questioned, and even broken. This approach naturally led him to challenge established views, including those associated with Einstein, but his challenges never felt like attacks. They felt like invitations to think more deeply. What made this honesty powerful was that it came without arrogance. Feynman never claimed final answers. He often emphasized that science is a method, not a collection of truths. Today's best explanation could be replaced tomorrow, and that was not failure but success. When he questioned Einstein's views, especially on quantum mechanics, he did so with full awareness of Einstein's genius. Yet he refused to let admiration silence his questions. That balance between respect and independence is extremely rare, and it is precisely what made his voice credible. Einstein valued this quality deeply. Despite his iconic status, Einstein never believed himself to be beyond criticism. He understood that unquestioned authority was the enemy of discovery. Feynman's honesty reminded Einstein of his own early struggles against established dogma. Both men shared a belief that science demands courage, the courage to stand by evidence even when it contradicts intuition, tradition, or personal preference. Feynman's integrity also showed in how he responded to being wrong. When evidence contradicted his expectations, he did not defend his ideas out of pride. He changed them. This willingness to abandon cherished beliefs in the face of new data is one of the hardest disciplines in science. Feynman practiced it relentlessly. That discipline created trust. When Feynman spoke, others knew his arguments were not shaped by ego but by evidence. This honesty extended beyond theoretical debates into real-world consequences. Feynman later demonstrated this same integrity during the investigation of the Challenger disaster, where he publicly revealed uncomfortable truths despite institutional pressure. That moment crystallized what had always defined him: a refusal to compromise truth for comfort or reputation. The same character that allowed him to challenge Einstein respectfully allowed him to challenge entire systems when lives and integrity were at stake. Einstein may not have agreed with all of Feynman's conclusions, but he recognized a kindred spirit. Respect in science does not require agreement, it requires sincerity. Feynman's questions were not designed to embarrass or dominate, but to clarify. That sincerity created a space where disagreement could exist without hostility. In that space, ideas could evolve. Ultimately, Richard Feynman earned Einstein's respect because he embodied the highest ethical standard of science. He showed that true respect is not silence, and it is not obedience. It is the courage to speak honestly, listen carefully, and remain willing to be wrong. By challenging ideas without attacking people, and by valuing truth over personal victory, Feynman demonstrated that intellectual honesty is the strongest foundation on which scientific progress can stand.